Today's webinar will be talking about solid probe inside SolidCAM, and together with me in this webinar is also joining us Eugene Eugene, who is the expert today in the solid probe in SolidCAM. Hello, Florine.
Hi, Sid, and hello, everybody.
Okay, so actually, let's get started with the webinar itself, and we'll start off first by showing you a little bit of a PowerPoint and to do a little explanation of what exactly solid probe is and why you need actually solid probe. Okay. Well, what exactly can you do with solid probe? Well, solid probe is basically used for your setup, for your home definition, and it can also be used for on-machine verification, such as for measuring different parts, different areas of the part itself, using the different cycle that's provided by your probe or by your controller. Now, today, if we go around to machine shops, in the old days, you used to have it where you just used to have an edge finder. Almost every machine shop would have an edge finder. They'd check all the their edges, manually onto the machine, and then put in the values. And if they had to do it in a specific spot, every single part, for instance, if they had a part where it had a circle in it, they would do that inside for every single part. And that's the way people used to work. But now, many machine shops, in fact, almost all machine shops, have a probe, whether it be a Renishaw probe or a Bloom probe, whatever a probe they may have, they have a probe. Now, however, today when people use a probe, they use it manually. What do I mean by manually? They'll go with the probe to the machine itself, and they'll feed it in slowly, step by step, to get one edge, and then get another edge, and then get the Z level, and put those values in for you getting your home position. Okay? Now, this is one of the things we can do inside SolidCAM, which will actually eliminate the need for actually going up to the machine and physically doing it. Another thing that should be taken into note when you're doing your home position with a probe is a very expensive commodity. It's not cheap. It's not like a regular 6mm end mill that, okay, it's not the best thing if you break one, but all right, it's not that much damage. But if for some reason you go to a probe and you accidentally do a wrong move with it and you break your probe, you can be out another $3,000–4,000 depending on your probe. So what we're doing here is also taking away the need to manually feed your probe into the part itself, whether it be for home positions or verification on the machine, or mostly in this particular case in home definition. Let's actually go further into the PowerPoint. Now, the probe itself, okay, we support 16 different solid cycles. Solid probe cycles. Solid probe actually supports different 16 of cycles that are available. Also, of course, it also depends on the cycles that are available from your particular probe or for your controller. Not every controller or probe supports every single one of those cycles, but we support every cycle that you may have. We support them. There are up to 16 of them. Okay, and Florine actually will be talking about this a little more in detail a little later on. Now, in fact, one of the things that we can also do is customize or configure parameters inside your VMID machine, your VMID or your machine ID on your post processor itself. And actually, I'm going to let Florine explain a little more about this. Florine?
Yes, we will talk about this.
Yeah.
Yes, we will talk about the parameters when I will be the presenter. I will open the VMID and detailed
Okay.
explanations.
All right. No problem at all. Florian actually has a more defined definition later on, and just to note that we have full control of it within our VM ID. Okay, now not only that, SolidCAM also has a tool specifically called probe. In this tool, you define exactly where your probe is going to be on the machine itself, the tool itself, and you see all these tools. You can see them all in all the types of simulations we have. In other words, SolidPort, we support the probe tool in all simulations that we have. Now, solid probe for home definition, which in almost all cases, almost everyone uses solid probe for defining your home position. Why do I need it? I mean, what's wrong with me going up to the machine and doing it? Well, like I said, there are certain cases. For example, besides the fact that I mentioned that you're talking about something that's extremely expensive and you don't want to make any kind of mistakes, but sometimes you may have repetitive setup that you may have to do. For example, you can easily say, all right, for a simple block, all right, you put it onto your vise, you have a stopper at the very end, and you put it up against a stopper, and sometimes that's enough. So all you really need just the very first setup, and then you put it in your home position into your controller, and that's it. You don't have to use your probe again. Okay, but sometimes that's not enough. Sometimes, for example, if you're using exact stock, putting it up against a stopper is not always that exact. You may have some dirt against your stopper. Your stopper may not be that secure, so you're not always that exact with it. Also, there are cases when working with your solid probe, with your stock, you may have to have a home position taken off a circle that's in the part itself. Why? Because you want to be exact. So putting it up against a stopper is not the answer in those particular cases. In those particular cases, every single part that you put on the machine, you have to check your home position. And if something is not exactly in place, you update your home position. Well, most people do that manually, okay? Or you have to learn all of the cycles that the machine has or the probe may have, and people may not know them all as well, and you program by hand. What we do in SolidCAM with the solid probe is very simple. It just defines the operation, the probe operation, and it will do it for you every single time. You don't have to go to the machine and check it yourself every single time. Put the part on, hit go, and the probe operation will do that for you automatically without any kind of human error or anything else like that. Also, where else may you need it? For example, stock that is casting. You know that a lot of times when you're working on casting, you're casting one part could be different than the next part because it's the casted part. They're not necessarily all exactly alike. So for each one of them, you always have to constantly redo your home position. So you would have, if you're using probe manually, you have to go down every single part and create another home position. Okay? With the solid probe, you do not have to do that. You put it in, you set from how far of a distance you want to check your home position, and it'll find it for you as a cycle already inside your program itself. Now, we talked about creating finding your home positions. Solid probe can also be used for on-machine verification, and Florian will get further into that as we go into the webinar itself. It's also good to know that because it's defined just like any operation, you could put it in between machining operations. So in other words, I can, for example, drill out holes, ream out a hole. Then I can come in right after that with my probe to see if the hole is is in the right place, right dimensions, and if it's okay, continue with the next operation, or say, okay, you know what, let's repeat the operation and I'll change my tool. Just an example. So you can do that in between your operations. Also, while programming with the probe, you can program your first home position, and if you have a second home position you have to put in, you just put in your second home position and then continue programming it. So it's working on the fly just like any other operation. There are also user-defined parameters for probe cycles inside your machine ID. And Florine, I believe you're going to go through this a little later on also?
Yes, of course. That's what
okay. Exactly.
we talk about it in detail.
Okay. Okay. Suffice to say at this moment that in our machine ID, we have all the parameters needed for the probe in the controller definition under probe. And we'll see that a little later on. And also in our operation, we have different, for inspection purposes, we even have tolerances, which I'll also show you in a few moments. Of course, we support multi-chain geometries. Geometries here are just like geometries in any 2.5D operation, whether it be a drilling type of geometry or a chain geometry, which support multi-chains. And you'll see exactly what I'll be talking about in a few moments as well. And I can even break up multi-chains in one operation to do different types of inspection on those chains. You'll see exactly what I'm talking about also again. So, and now as far as what controls we control just about every single controller that's out there, whether it be a Fanuc, Heidenhain, all of them we support inside SolidPro of SolidCAM. Now let's actually go into the part itself. And what I'm going to do is switch over to my other screen. Okay, you should be seeing it now. And what I have here, my first case is a simple case where I have to machine the part as shown over here, and I have this stock around it. No, my home position is on the corner of the stock, okay? But if I look in the Z level, you can see, I'll try to zoom in a bit on the Z level, you can see it's a little lower, and I can tell you right now, it's 0.3 millimeters above the actual part itself. From that surface to this surface here, to the top surface over there, it's 0.3 millimeters. So, and what I'd like to do is to create a probe operation where I first check my upper level to put into the for my home position, as well as checking the corner over there for the X and Y. Okay, so the way we work in probe is very, very simple, very similar in many cases to your regular operations. I'll go to probe. As you see here, we have an operation called probe. And remember I talked about supporting different cycles? Over here we have a list of all the different cycles that we support. Of course, that depends if you're what your controller supports as well. Okay, so the first thing I like to do is choose a single point Z level. In other words, to pick my top of the surface. And note also over here, what action am I doing right now? We have either home position or measurement. Right now I'm doing my home position. Mac 1, position 1. Okay. Now, to create my home position for a Z geometry, that's a specific point. So let's take a look at it from the top view. And I want to put it approximately in the middle. It doesn't have to be exact in this particular case. If I needed something to be exact, I would put a point over there, but I don't need it. This is just enough over there. Okay? You can see that I've chosen, it's inside my, my geometry list, and that's it. Just like choosing a drill point. Now, the tool itself, as you can see, the tool that we need is a probe. If I go to select, okay, I already have a probe here. By the way, creating a new probe is just by, as you see, it brings in a new probe tool. But I don't need that one. I already have one here. And I want to use this probe over here. Note also in the probe, all we need to do is put in our diameter of the ball itself and our shoulder diameter over here. And of course, we have our arbor diameter on top over there as well. And the rest of the stuff just like any other tool. So I'll just select it. And now let's go further down what I need over here. Levels, I don't need anything really, just my clearance level. That's all I have over here. Now, we have our technology lists. We're doing our technologies on one particular point. That's all this is showing us over here. Okay? If I click on my preview button, you can see that it's going on that one list point over there. So now let's actually go into the technology and see what we're doing. Well, let me first zoom in over here. And you can see the following. You can actually see when I use my preview, you can see the actual tool where it's starting off. That's 25 millimeters above. And then we have 2 points, a touch point and the point from where it actually starts going into the part itself, where you're actually starting from. How do we control exactly what height we're at? That's right over here. First of all, the distance. If I want, just by rolling the middle button on my mouse, I can have it go higher or lower in distance. And you see it directly on your screen. Okay. Now my Z level at the bottom, right now it's at 0, but I don't want it at 0. I want it at 0.3 millimeters, or I can actually pick it from the part and just click on the top surface over here, and I'll get 0.3 millimeters. And that's it. That's all I needed to do. I'll save and calculate. And now I also said I want to do the corner as well. So what I'll do is I'll do simple save and copy. This way I already have the tool in here. And I'll change this over to, we have here an option for external corner. If I click on that, you see that's exactly what I need. One edge and the next edge over there. So I'll create my geometry. Again, home position. And in this particular case, I'm going to choose this line over here as well as this line over there. And that's my corner where I want to have my home position. Levels, they're the same. Let's go directly with my Tech 1. And we'll click on Preview so you can see exactly what's going on. Let's take a look at the top view. Now zoom in so you can see exactly what's going on. Well, you see everything's coming into the 0 point. Let's see the different controls that we have. First of all, distance along X. Note, that's the distance, how far away I want to stand from the part as I'm working my way into the part itself, as well as Y itself. Now, as far as where along here do I want to check and this way, that's what we have over here. Note, I can say, okay, let's move it out that much in my X direction. Okay, you can see that over there. And that's exactly where it's going to hit on the stock. Now my Y direction, let's take another look at the very top view and zoom in over here again. You can see we have the X and we have also the Y. I want to have the Y a little further out towards the middle of the part. And that's it. Wait, one more thing. And of course, if I look at the side, I can also say, okay, we're in the Z level. Let's go further down. And see, just by rolling my mouse, I can move it up and down, and everything's visual. You can see everything that's going on as you're programming it. Okay? Save and calculate. Now let's do a quick simulation. And we'll simulate this. First, let's do a regular HostCAD simulation. You can see the tool will come down, touch the top, touch one side, and touch the next side. And that's all there is to it. And your operation is done. You don't have to know the cycles by heart. And this will be controlled on your machine automatically. No, you don't have to worry about moving in by hand or on either side. Okay. Now that I did that, I created my home position, and that's how it's going to work on the machine. Of course, then we have our operations. So as you can see, let me just run. I have different types of operations, such as my face mill for doing the top, and I have some eye machining roughing operations. Actually, let me just run the simulation on this using Solid Verify. And as you can see, it starts off with the probe, touching off on the sides. And now we have our operations, whether it be our face mill, our eye machining, roughing as shown over here on all the different levels. And of course, you'll note that I am using eye machining because that's probably the best way, not probably, but that's the best way to remove material quickly and the most efficiently as well. Okay. As you can see, it's moving all the material exactly where it needs to be, including those areas over there. Everything's being machined out. And then we're going to have some eye machining in that corner over there, some milling operations, and we also had chamfer removal on this part as well. Okay, everything is done nice. Now, let's say I want to go and inspect some, before I remove it from the machine, I want to do inspect something, okay? For example, on this part, I have another part after this, but on this part, I want to measure this cylinder over here, and I also want to measure the outside dimensions. Okay, for example, well, I like to work in configuration, so I'll go to my default configuration, and as you can see, this is the actual part itself. A lot easier to see this way. Okay, so now let's go into my probe operation. But this time, since I'm measuring, I'm going to use the option of measurement. Okay? Now, I want to first check the cylinder over here. So if I go into my technology, we have an option of cylinder, as shown over here. Okay? I'll click on cylinder, create my geometry, which is that circle over there, and that's it. Choose my tool. I'm going to use my probe I had before. Now let's take a look at this again from the top view. We'll go down to our technology, and we'll do preview. Okay. As you can see, we have it around the part. We have also distance. You can go further away, less further. Now, let's say I want to stand this distance away. However, I don't want to, I'm a little afraid just by visually, because I'm saying, you know what, maybe this wasn't machined and stuff like that. I don't want to actually go down directly over there. I'd like to actually move it over here to go into the part. Note it's also tapping off the part in 3 different points. Okay. Well, what I can do is simple. Look at this move start point. If I just put my cursor in there and roll my mouse, you can see I can actually turn it to a safer area. Okay. Now, if my probe supports more than 3 touch points, I can go over here and add touch points as well. 4, 5, 6, okay? Depending if my probe supports it. But let's just leave it at 3 for now. And the depth. If we take a look, we have our Z level. I can go further down if I want. I'm going to put it there 3 millimeters down. Further, as you can see, visual is enough for me in this particular case. Okay? I'm going to save it. And now I'm just going to continue with my next operation. Okay? Save and copy. Okay? And I want to check the measurements on the outside. Now one thing also I forgot to mention to you, that if I go to Tech 1 you can see since I'm working in measuring the part, we have the parameters over here that you can put in different tolerances. Okay, and Florine will talk about that later on also as far as getting a report about this as well. Okay, so let's actually go back to my geometry over here. And instead of cylinder this time, I'm going to choose boss. Okay, where I'm clicking, as you can see, I want to check this from all sides. Now, my geometry in this particular case is going to be the outside of the box itself, like a regular chain geometry that you would normally have. Okay, I already have my tool. Let's get rid of these V marks over here. And now we go down to our levels. We go down to our Tech 1. Note we have options over here called measure along X, Y, and X and Y. Now, not every controller supports in one cycle to do X and Y. You can do either X or Y, but not both of them together. So let's say this is one of those controllers where you can't do it. You can only do either X or Y. So let's choose X, for example, okay? And we'll do preview. You can see exactly what's going on over here on the part itself. And again, my Z level, I'll pick it up a little. And you can see that visually as well over here. Okay, now you may say, okay, for my Y, I need a different operation. Well, now let's get back to our technologies, okay? As you see, we have one technology what we're using. If I want, and that has one chain in it. If I want, I can right-click over here and add another technology. This other technology is obviously also using that same chain. Now if I go over here into Tech 2, all I need to do here is have this go in Y. So in one operation, I'm having two different cycles, one for the X and one for the Y. Again, I'll set my preview and have my Z level exactly where I need it. Okay, everything's done. Save and calculate. Let's run now a simulation, just the last part over here on Solid Verify. You can see it going now and measuring around the part, the X and the Y, as shown over here. This is what this particular machine supports, this controller supports. And that's how it's done simply on the machine itself, without needing to take the part off the machine. Okay. We'll talk about this a little later on also, but now I'd like to load a different part. Okay? With the next part that I'll be loading is going to be actually a little bit of a different situation. Okay. If we take a look at this part, you can see our stock. Now, in this particular case, let's take a look at the top view of the stock. My stock is exactly, this is a pre-machined stock, where the sides are exactly up to measurement already. In other words, when I place this on the machine, I have to place this exact. Okay? No room for error because everything here is ready to measurement. Okay. The only thing that isn't to measurement, as far as the outside dimensions, is the depth. There's still some material to be taken off the top. But also note, the way this stock was created to help me out was they put a circle in the middle. So I can actually create my home position exactly in the middle of the part. Now, if I were to do this by probe, and without the use of SolidCAM Solid Probe option, you would have to go every single time you put a part onto the machine, excuse me, Every single time you put a part on the machine, you'd have to go up to the part physically and put your probe on, check it, and have it update your home position. And God forbid you make a mistake. First of all, it's time consuming every single time to do that. Okay? And if one time, all you need is one time to do a little extra move with that probe, break your probe, you're down again all that money. But then again, also besides that, don't forget about the time involved of every single part that you have to check your home position. This is why we can do it, or this is another phenomenal reason why you need to do this using SolidCAM's Solid Probe option. Okay, so let's see exactly how I'm going to do this. We'll start off with our probe operation. Okay, we'll go to probe. And again, home position, I'm going to start off with my Z. Okay, as shown over here, I'm already in Z. I'll create a geometry. Now this time I'm not going to create a geometry exactly in the middle because I have a hole there. But I'm going to create my geometry just off to the side over here for measuring the Z upper level. Okay. The tool again will be the probe that I have over here. Okay. And just like before, my Z upper level is going to be over here on the top of the surface over here, 0.3 millimeters. Okay, that's fine. Very similar as before. Now, we'll do save and calculate, and we have that operation. But I now want to do one more for the center of that hole. So for that, we'll do as follows. Save and copy. We'll change single point Z to hole. As you see, we have a cycle specifically for a hole. Okay? Creating the geometry for a single hole. No problem. Let's go in here and create our geometry. Now, geometry, I'm just going to click on the edge over there. Direction, by the way, does not have anything to do with it. Okay. The tool I already have. The technology. Let's take a look at my top view using the preview of the part. Now zoom in over here. You can see that it's going to be touching off in 3 different areas. Coming down in the center. You can see also we have control of how far away do I want to stay from the walls, closer or further away, 3 millimeters away or 2 millimeters away, or closer to the actual center itself. Anyone, whichever way they feel that they're more comfortable with. And, of course, my Z level, I can pick that up as well. Okay? I'll have it over there. That's it. So now, let's run my simulation on these 2 operations. Now do this with Solid Verify. You can see, first of all, we have our hole there in info. Just going to run my simulation. We'll slow it down. Actually, I'll do one step at a time. You can see we touch off on the Z top. Now it comes to the center. 1, 2, 3. And this will do this repeatedly every single time you have this on the machine. You don't have to go back manually. It'll do it for you every single time. Okay. Of course, we have our operations, and I've done those already. So let me just run a quick simulation on the actual operations itself using Solid Verify. And I'll do it on all the operations, my fault. Okay, you can see we have our face mill. We have I use Toolbox for clearing out the corners over here. As far as O-ring, I had the drilling operations done with the hole wizard recognition, and that's basically all I really needed. Everything is finished off over here. Now what I'd like to do is I'd like to do a little bit of measurement. And the measurement I'd like to show off this time are these holes over here. Now, let me go into my configuration. We can show you the actual default itself. It's a lot easier this way. And I'd like to measure each one of those holes. Well, there are a lot of holes over there. If I'm not mistaken, there is that 36 holes over here on top. When I measure these holes, I'd like to measure them at different depths. In other words, I don't want to measure all of them at the same depth. Okay? Maybe this group at one depth, this group at a different depth, and so on and so forth. Maybe I want to also make sure my tool wear can be, maybe if I do it all on the top, maybe have some tool wear at the bottom. Okay? So I like to check it at different points. So the way we do that is very simple. Let's go and create a probe operation. Okay? And this time, instead of, first of all, home position, we're going to use measurement. And measurement, I'm going to use the hole option. Now, let's choose my geometry. I believe I already have a geometry here. Let me see if I have it. No, that's not it. I believe it is, just make sure I'll go down the line. Let me see. There we go. That's the geometry I want, all the circles. Okay, and we can show them. The tool obviously will be my probe. Okay, and we have our Tech 1. Now, at this point, the way it is right now, they're all being done at the same level. You can see them all going down. But like I said, I don't want to do that in every single hole. I'd say let's say these sets of holes, I want to have it going down at -3, and this one -6, 9, and 12, and so on and so forth. So let's go now to our technologies list. You'll note we see all our geometries in our first technology. Okay? Now remember before how I added on technologies? Well, first of all, let me get rid of all the chains, and I'll say in this particular technology, I only want to do the first 9 as shown over here. Those are the ones I'd like to do. Now, I can add a technology, and as you can see in my second technology, I have the chains over here again, and I can say I want to do these now from 10 through 18. Okay? So we had our first ones there. And as you can see them over there. Now, and in this level, I want to have that at -6. Okay? So let me do these actually for all of them. Let me do now, add another one over here. This one's going to be from 19 through 27. Okay? And I'm going, sorry, my mistake, here we go. 19 through 27. And if I right click here, we'll add another one. And this one's going to be from 28, sorry, until the very, very end. Okay? So I have different technology groups. So now I'm going to, when I go into Tech 3, I'm going to have my Z level at -9. Okay? So that's going to go further down than it was before. And if I go into Tech 4, I'm going to have that at -12. Okay? So if I go, I have my Tech 4, 3, 2, 1. All of them at different levels. Okay? Save and calculate. One operation takes care of the levels on every single one of those holes. Let's take a look at the simulation of this now. Okay? You can see it's doing the first set. And it takes the ball into consideration, so it's -4.5. This one is -7.5. Next one, as you'll see in a moment, is going to be even further down. And the last set is going to be even more than that. This is 10.5. This is going to be 13.5. So you see we have very good control as far as where we want to do our check. The bottom line of what I'm showing you over here, and in a moment we're going to get into some explanations about the machines itself with fluorine, but the bottom line is every single tool shop out there today using a probe on the machine, having solid probe is practically a must. It'll save you so much heartache, so much time as well as far as your setups. And if you have the package as well for inspection, it'll help you out immensely for inspection. Okay, Florian, why don't you continue now and explain a little bit more about the options that the probe gives you as far as the VMID or the different types of packages as well.
Of course, Sidney.
Of course.
Yeah. By the way, great presentation, by the way.
Thank you. Okay, just one moment. Let's see. Here we go. And you are now the presenter.
Okay. I hope you see my screen now. I have the same part as Sid for some examples. But before that, let's talk about how the probe is working, how SolidCAM is connecting to so many devices, so many different devices and different cycles and different controllers on the market. And if we are looking at the packages of measuring cycles, and I'm looking here on Inspection Plus for FANUC, we see that generally they do the same action. Maybe the name of the cycle is different, the number of subroutine in the controller is different, but the action at the end will be the same. So we have for a FANUC single surface measurement in X, in Y, in Z. We have web and pocket. We have bore and boss, internal corner, external corner, and some more cycles, advanced package of measuring cycles with vector measuring cycles, and so on. But if I'm going to another package, and this is a Bloom, yes, I have different names. I have a single point. For FANUC, I have single surface. Here I have single point, corner, inside width, outside width, inside diameter and outside diameter, but they will measure the same. Also, if we look at the pictures, we see the same. We have some common parameters, which should be the width of the feature that we measure, the Z level, R, the safety point, and those parameters are common on all cycles, also for Heidenhain, Siemens, and any other controller. Let's go to Heidenhain and look at reach. The same, we have 2 points measurement, for example, and the cycle is 409. Different parameter Q 311 is the width here. So there are general common variables that we need, and we design our interface in SolidCAM to support all of them. And there are specific parameters, for example, optional inputs here, which we can define them specific for each controller, for each controller type. For FANUC Inspection Plus, for example, optional inputs, we have B, E, F, H, a lot of optional inputs. And let's see how we can support this customization, because we need to customize our interface. For this, we have the machine ID editor, and in controller definition, we have the probe. We select the probe. Can be a Bloom, a Niken, any other type, and we will define which cycle is available on this specific controller, home position only, measurement only, or not supported, or both of them are available. For each cycle we can define. And also we can define parameters. What we see here in these optional inputs, we will define them here for all cycles, or maybe the parameter should appear only on specific cycle. Angle tolerance, experience value B, E, F, and whatever we need, we define here. Those are additional optional inputs which we can define them very easily here. And after that, we can use them in technologies, parameters. The parameters will show here and we can use them. I want to use the true position because I'm using a measuring action now. So let's check the true position and I will get this parameter in the cycle. So this is the way that we handle different types of cycles. Another issue is there is not only the different output in G-code, but going from one controller to another. Let's look here again. Going from one controller to another, we also have different movement in simulation. So when I define a controller, this is Fanuc, or this is Heidenhain, or maybe Siemens, or Meisac, or Okuma, we also have a different movements. In Fanuc, for example, the movement will be X, each axis going in plus or minus, and Y after that, plus and minus. The movement go through the center. Heidenhain is going around the center, will never go through the center. So when you choose a different controller, different machine, you will see a different simulation. It's also help you to have to see the real movements on the machine. Another option is okay, we define a home, we machine the part, and now we measure. We have the option to measure the part on machine. Many users ask me, "Oh, why should I measure the part on the machine?" So there are many reasons for that. Not always you need to measure the part. Not always at the end of the machining process. You need to measure the part in the middle of process, and you don't want to take the part to the CMM, to the XYZ machine, and to measure and came back. So here you have the option to measure. Sometimes the part is so big, and I will show an example of part now. I have a customer with a plate 5 meters long with 2 meters width and more than 10,000 pockets in here that he needs to measure. First of all, he don't have a CMM machine, an XYZ for this part. So it's a very expensive machine for those dimensions. And the tolerance was not so close to measure hundreds, 0.01. The machine can handle it. We don't need maybe microns here. So the best solution was buying a SolidCAM module and a probe module and create a program very fast, transform with the matrix. Also the transform is working as in any regular operation. You create one operation measuring one pocket and you transform matrix 100 times in X and 200 times in Y, and you have the whole program ready. And this user finished the measurement. After that, you also have the option, again, not depend on SolidCAM. SolidCAM use whatever controller you have, options you have in the controller. So if you have the option to print a report, and generally they have, it's a standard option. If we are looking at optional inputs, going to W will tell to the cycle to print out the output data, so to print a report. And also, if we are going to Heidenhain, we can have a report recording the like this example. Heidenhain will save a file in the controller. The same with the phono controller. He can save the file on internal flash drive or to send the program through RS-333 port to the computer and save it on the computer. There are different options, but this is an example of sending a report and check it later. Now, let's say I have some examples of reports that we create, and depend on tolerance that we have here in the parameters, center in XYZ or distance in X-axis. This is for the boss, yes. If I'm going to a hole or a cylinder, I will have the diameter tolerance and so on. This is changing. So depend on the tolerance that the user can complete the input in these fields, we will get the report and the results, deviations. We have the tolerance 0.1 and deviation is 0.004. So for each pocket we have a different deviation. We measure here something like almost 400 pockets for you, and the user can go through this file and search, just looking into the results and check the part. So those are the options, and make your life easier and programming easier. Another example, I have also Siemens here, and look at here. The same actions, the same measurements, but different names. They call hole, shaft, groove, inside rectangle, outside rectangle, but at the end they will do the same. So SolidCAM will use the package of cycles that you have in the controller. In Siemens they are built in. In Heidenhain also the cycles are built in. For Fanuc, for a rainy show, we'll install this package of measuring cycles in the controller, also Bloom, and there are many examples of measuring devices on the market. Each one of them will come with his own package of measuring cycles. Now, beside the standard options that we have here, one surface in XYZ, angle, measurement, boss pocket, and boss with pocket, cylinder and hole, measuring of radius, external or internal, corner, external, internal. Sometimes you need some advanced features. User asks me, okay, I want to measure to find the center of this feature, and to find the center of this feature and to find the distance between them in X and Y. Do you have a cycle for that? I said, no, I don't have a cycle for that. And we will not create in our interface specific cycle, advanced cycle like this that only maybe you need. But we can combine. Our power is to combine the cycles, and you will get the results of what you want to get. So I will use the standard cycle with measuring and finding the center of this feature. After that, for each measurement, the results of the center position in X and Y, they are saved into the machine, into the controller variables. After each measurement, this data is saved into the variables. So we can use this. I'm going to combine with a machine control, and with a message, I will save the information saved in variable 135, the X center, into variable 600, and Y center into variable 601. Okay, why? Because next time I will do the measurement, those values will be updated. That's the reason. Now I'm going to find the center of this feature. And again, the variable 135 and 36 are updated to this new position. Yes, but I already saved them. Now, again, a new machine control operation with a new message. I will save the new center in X, new center in Y, in a new variables. And at the end, I will calculate the last center in X minus first center in X, and I will get the distance between them in X. Also in the same manner, I will find the distance in Y, the difference between those two saved values in the controller. So this is only one example of combining machine control operation with probing operations and get some measurements, get some information that you need in the machine.
So basically it looks like, Florian, that you can actually get just about anything you really need, even though you don't have a cycle for it, but just by using your machine control and the parameters, you can just about get any measurement that you need.
That's correct, Sid, yes. Combination with machine control and probing cycles, and we can get anything that we need.
Really good. Really nice.
So, and that's it. That's it. Maybe we have any questions?
We have one question here, actually, and it's I think I know the answer, but I'll let you answer it better. The question is as follows: Can you it asks, can you only probe the original stock or the final finished component? For example, can you probe a semi-finished part in order to set the precise tool radius offset to maintain accuracy?
Of course, but again, this is an option that depends on the cycle. And if we are looking here in this cycle and optional inputs, okay, let's see, we have the T parameter. Where is T parameter? The tool offset number to be updated. When I measure, and let's go to web pocket. When I measure, for example, this pocket in X or in Y, and I will use the parameter, the variable T, the deviation of this pocket will update the tool. So I have a tool with radius 6 millimeter, a 12 millimeter end mill, and the results of the measurement is smaller than the expected value. The radius of the tool will be updated in the tool table. You just need to repeat the machining operation again, the operation where you milling, where you have the milling of this pocket. Again, the tool is already updated by the measuring cycle using optional input.
Okay, Florian, I think his question was a little bit different. What he meant was how do you measure an in-process stock model geometry? And let me try and answer this, and I'll put it over to my screen for that. I'll make myself a presenter. Just a moment. Let me see. I will make myself presenter, and I'll show my screen. In any single operation, for example, we have, like I said, we have this counterbore operation that I have over here, okay? Or this drilling operation that I had, where was it? Yeah, this drilling operation that I had over here. I believe that was this. Yeah, this is what I want. I can go in over here and add a probe operation, okay? Just putting over here, probe operation, measure it, okay, on that particular geometry over there, and then I can go and have another operation after that. Get the results I need, and then just continue on with another operation. Now, when I do this, I can also set in my technologies. I didn't choose anything over there. You know, you basically see exactly what you're going to get, and you see how much you have left over, and then you can just continue on into your next operation. So you do have the capabilities of checking in between, of putting operations in between. Okay. Florine, I think we're finished.
Yes.
Obviously, this webinar has been recorded, and you'll see it on our website. By tomorrow, you should be able to see it on our website. I'd like to thank everyone. I'd like to, first of all, thank Florine for his excellent explanation of actually how the actual probe works, even more so than what we have actually in SolidCAM, so we understand what a probe exactly is. And I'd like to thank everyone for joining a webinar. So see you again on our next webinar. Everyone have a great day. Take care.
Bye-bye.